Hey everyone, today we're going to talk about the magnificent U-substitution. U-sub is basically the holy grail of integration because you literally use it for almost any integral on the AP Calc exam. Think about it this way. Imagine you're trying to eat a messy burger with your hands. It's impossible to eat it perfectly. So let's get back on track here. U-sub acts as a tool, quote unquote, for simplifying integrals, just like using a fork makes eating the burger easier. Okay, so we have an example integral here, just chilling about and doing its thing. So when working with U-sub, you'll want to first replace a complex part of the integral with a simpler variable to make the integration easier. As it's called U-sub, I wonder what the variable could be. It takes a lot of brains, but we use U. Back to the example here, we first see this messy part with terms in it, which highlights the need for simplification. Also, I forgot to say this, but if it helps, it's like the chain rule in reverse. So you want to use U-sub when you see a function inside another function. Alright, this looks messy, but notice, the derivative of x squared is 2x, and we have a 2x in the front. We'll talk more about this later in the example. Alright, so this derivative of x squared being 2x is the clue to use u equals x squared. I mean, this definitely seems confusing at first, but just wait and see how it works out in the end. Alright, because u equals x squared, then du over dx, basically derivative u in respect to x, is 2x. Also, if you want to understand this better, you can use this more widely used method to find dx, and this is by taking the derivative of both sides of u equals x squared, then rearrange that to eventually get dx equals du over 2x. So now what we want to do is plug in all the u's into the integral again. And so now we write integral 2x times cosine of u and then du. But here's the thing, that doesn't make sense. So yeah, this does not make sense because we have 2x there and a 2x there, and the integral is in terms of du. So what we want to do, this is the perfect position to cancel both of them out. So we get a proper integral of cosine u du. Okay, now we still have to do more steps. Alright, I wrote out the integral again for you to make it much more clear. And now, look at this integral. It's much more easier than we have in the blue and purple right now. So, what we gotta do next is first integrate it, right? So, how would we do that? By trig identities, we know that integration of cosine is sine. So, now we get sine of u plus c. Remember, do not forget the plus c. Plus c is very important. So, just remember when you're taking your exam, always have the plus c on you. Okay, so I have sine u plus c over here because we're not finished yet, because we have to substitute the x squared back into the u to actually complete and solve the problem. So what do we get after this? We get sine of x squared plus c, and that is just your final answer. And now you have what you need to ace the exam, but there's still more things we have to talk about today. Okay, so now we have this new integral here. It's a more complex example. And now we see this x squared plus 1 looks very messy. So, because it's messy, we have to know what our next step is. And our next step is finding what u equals. So, what's the messy piece? We have x squared plus u. Plus 1, I meant, sorry. And so we know that u equals x squared plus 1. And so our next step would be to find what du equals. Well, so du over dx is basically u prime. And so what is u prime? U prime is 2x. And because u prime is 2x, du over 2x equals dx just by rearranging it. It's a very simple idea, but it takes practice to put into mastery. Alright, let me just erase all this real quick to make more room for ourselves. So, we have u equals x squared plus 1, and du equals dx, and du over 2 equals dx. My bad. Okay, so can you spot something here? So I spot this x and dx in the problem and in the du over 2x equals dx. So we can write this as du over 2 equals x dx. And if you see where I'm going with this, we can perfectly evaluate this integral because they'll just cancel out in the end. And so now let's rewrite this heck of an integral. Actually, first we should rewrite this du up top. So we have du over 2 equals x dx. And now that we got that done, our next step should be rewriting this integral in terms of u. And so we get the integral of something over u cubed. What's the something? It's 1. It's not x because du over 2 equals x dx, canceling it out. So we get integral of 1 over u cubed times du over 2. Because the x dx in the original integral is replaced by du over 2. So we can take this 1/2 and put it outside the integral, and then we get reformatted as 1/2 integral of u to the power of -3 du. And now this can go to 1/2 parentheses u to the power of -2 over -2 integration plus c. And you're almost at the answer now, because the last step is to substitute in the x value into the u value. Let's go ahead and simplify this just a little bit more. And so we'll get, let's see, -1 over 4 u squared. Let's see. So as we sub back the x's into the u, we get -1 over 4 in parentheses x squared plus 1 squared and parentheses plus c. And this is probably going to be your average U-sub problem you'll see on AB or BC. You might get a little bit more trickier ones though, in combination with other integration methods like integration by parts and partial fractions. But we'll worry about that for another time. Let's move on for now to some common mistakes we see in the exam. Our first common mistake is forgetting to change dx into du. So here's a quick example where we have this integral here and u is x squared. So what does this actually mean? So by forgetting to change dx to du, that means in this problem we see there's du over 2 equals x dx. And that 1/2 plays an important role in the problem. So if we forget to change this dx to du, we're basically removing that 1/2 out of the entire integral. And by doing so, the problem is you're not going to get the correct answer on the actual exam. So always remember to substitute u value and the du values into the dx, just to make sure you're all okay during the exam. So the second most common mistake students face during the exam is substituting part of the expression. And we gotta emphasize part of the expression. Because let's take this example integral over here. So we get this entire thing, and so we have this base integral, and the actual answer is negative 1 over 4 x squared plus 1 plus c. But if you do not substitute the du in for the equation and just leave a dx there, oh, I meant to put x over u cubed dx, but it's alright. So, because of this, we can't move further in the problem and can't get the actual final answer of negative 1/4 x squared plus 1 plus c. So, by that, always remember to make sure all the variables in your integral are the same variable after simplifying. Alright, let's move on to the third and final mistake, and this is the most common mistake students make. And this is a big one, is forgetting to sub back u at the end. Alright, let's see this example of the integral of 2x sine parentheses x squared parentheses dx. Alright, so looking at this problem, we find u to be the inside part, complex part, which is x squared, du equals 2x dx, and therefore du over 2x equals dx. And now we can turn this into integral of sine u du, and then more into, after integrating it, negative cosine u plus c. So we get this final answer, and this is not equal to the actual final answer because we have to put back x squared into u. So the real final answer would be negative cosine x squared plus c. And just remember to do that because this is a really common mistake we see in the exam. Alright, thank you for watching my video. And if you need more practice, I link some practice problems in the description for you to find and do. I really suggest doing them so you can improve your skills in trigonometry, the polynomials, and radicals. Alright, see you guys next time.